Okay, so we're going to look at what we're going to be doing here. We're going to, first of all, our learning goal says, who wants to read it for us, our learning goal? Caden?
Describe even, odd, and prime numbers using
Algebraic expressions, right? Okay, so we're going to work with being able to describe different types of numbers, specifically today, even odd and prime, using algebraic expressions. In other words, how can we work with them with some algebra involved, okay? So we're actually going to do this number 1, but we're going to do it on the other page, so we're just going to look here and see what the directions ask us to do, okay? So we're at this one right here, and that's what the other handout is for. Write each number as 2 times n, or, so let's underline that, as 2 times n, or as 2 times n add 1. So those are both algebraic expressions. We have the algebraic expression 2 times n. We have the algebraic expression 2 times n plus 1. And it says up in the directions, it says the variable n, let's circle this, the variable n represents an integer. Okay, the variable n represents an integer. What's an integer? Remember, what's the definition for an integer? Oh, we've forgotten. We gotta get this down. An integer is any whole number and its opposite. So give me an example of a whole number. Wait, 5. What's its opposite? Negative. And then both 5 and negative 5 are integers. Give me another example of a whole number. Sylvia? 10. What's the opposite of 10, class? Negative 10. So both 10 and negative 10 are considered to be integers. And then there's that whole number 0. What's its opposite? Itself. So 0 is an integer also. So we are, when it says that the variable n represents an integer, now we have an idea of what they're talking about. So we have the numbers 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. And we have to write each of those, give each of those, assign them one of those algebraic expressions. So let's go back to that, let's go over to that other handout, and let's do it in this table that I have set up for us. This is where we will show our work, okay? So the number 10. Can you think of an integer that all you have to do is multiply it by 2? Danny? 5. So in other words, if we took 2 times 5, that would be 10. Okay? Can anyone think of an integer that if we took it times 2 and then added 1, we would still get 10? Can you think of anything you could multiply by 2 and then add 1 and you would get 10? No? Okay, well then we'll move on. How about 11? Can you think of anything that you could multiply by 2 and you would get 11? But remember, n has to be an integer. So think you got one, Wade?
Well, I was thinking it would be the same as 2 times 5,
But then you'd have to add 1, wouldn't you? So you can't, can we think of an integer though that you can just multiply by 2 and not have to add 1? Do you think there's any way to get to 11 by just multiplying by 2? So I think we're going to have to do what Wade said. We're going to have to go over here to this column and take it times 5 and add 1. Because what's 2 times 5, class? 10. So now we have 10 plus 1. And what's 10 plus 1? 11. Okay. How about the next one, 12? Which column, or can we find something to put in both columns for that? Can it be identified by both algebraic expressions? I think somebody new that hasn't participated yet. Harley? 2 times 6, and that's it? Just multiply by 2 and that should give it to us? So over here in this column, take 2 times n, our n is going to be 6. 2 times 6 is 12. Can we think of any number That's an integer that if you multiply it by 2 and add 1, you'll get 12. No? Okay, then let's move on to 13. How about 13? Which algebraic expression can represent 13 and what would n have to be? Sammy, what do you think?
2 times 6 plus 1.
2 times 6 plus 1, she says. What's 2 times 6 again, class? 12. And 12 plus 1 is 13, and that's the number where you want to represent, is 13. Starting to see a pattern developing here? See if you can fill out the rest of the table. Go ahead and try. Fill out the rest of the table. See if you can get the rest of it now. Showing like what we have been showing here. When you're done, will you check me out and see how I did? Are you all right? Please check mine out. I don't want to be wrong. How long could we keep this pattern going? Forever. But the numbers eventually get quite large, and you get pretty sick of it. But this pattern is reliable, it's consistent, it can be counted on. What do you think? Yeah? Okay. So in other words, if I did ask you to give me which algebraic expression the number 200, which column it would fall in? Would it be the 2 times n, or would it be the 2 times n plus 1? Would you be able to answer that without having to keep this table going until you got to 100? Yeah? Okay, who thinks they know which one it would be? Cheyenne? 2 times n, because what do we have to take times 2 to get 100? 2 times what is 100? 50. 2 times 50 would be 100. Okay, so then give me a number that would be a 2 times n plus 1. Somebody give me another number, not from our table, but somewhere later on, if you were continuing this table on, give me another number that would be in the 2 times n plus 1 column. Maybe I can make you extend this all the way to 100. Harley? 23. Okay. Because if we follow the pattern, okay, let's go back to our other sheet now and keep this one beside it, okay, so that you're going to be able to reference it. Let's go back to this sheet and let's go to number 2 where it says, which numbers work for 2 times n? So I want you to just circle all the numbers in that list of 10 through 22 for which they were in the 2 times n column. And then decide, what can we say about all of these numbers? What kind, what type, what special name can they be called? Ikea? These are the even numbers. The even numbers. So even numbers can be represented by the algebraic expression 2 times n. Okay? So 2 times n will always give you an even number when n is what kind of a number? When n is, starts with an I. When n is what kind of number? If you take it times 2, you'll have an even number. An integer. An integer. And did it matter whether our, so when we did it matter what you were multiplying by? I'm going to go back to my table, and you guys go, you look over at yours. Notice, did that integer have to have any special quality? 5, 6, 7, 8, 9, 10. Were they evens necessarily, or odds, or any special quality with the integers? No, they were just integers, weren't they? So 2 times any integer will give us an even number. Okay, let's go to number 3 then. In number 3, you're supposed to circle all of the numbers that worked in the 2 times n plus 1 column. Which ones are in that one? So get those circled. And what are these numbers called? Wait a moment. These are the odd numbers. These numbers are called odd numbers. So if we want to represent the odd numbers, we would say to double an integer and add 1, and you will get an odd number. Double any integer, add 1 to it, and you will get an odd number. So those are patterns we want to remember. Anybody have questions about it? So this shows up on your homework, you're going to be able to understand it. Okay, then let's go on to number 4 for another pattern that we don't have a table for. Which of the numbers in this list work for n over n equals 1? Or in other words, n divided by n. So an integer divided by itself equals 1. So let's circle that. There's one of our algebraic expressions that we're looking to see what kind of numbers can be called n divided by n, and this one is an equation equals 1. And then, but they also satisfy this one. I'm going to do that one better. They also satisfy that one. N divided by 1 equals n. Or in other words, an integer divided by 1 equals the integer. An integer divided by 1 is equal to itself. Okay. But they're not divisible by any other number. So in other words, this is the only, they fit both of these, but they don't fit the 2 times n or the 2 times n plus 1 category. So can you tell me which of those numbers in that list do we have any? How about 10 divided by 10? Is that 1? Okay. Is 10 divided by 1, 10? Oh, but is 10 divisible by any other number other than 10 and 1? Yeah, it's divisible by 2 and by 5. Okay, so 10 can't be in that list, can it? It says it has to meet both of these, and it can't be divisible, are not divisible by any other number. So anybody think they know any numbers in that list that might qualify? Any numbers in that list that might qualify? Kate, you got one? 11, he says. So 11 might qualify. Let's see. Is 11 divided by 11 1?
Yes.
Okay. So 11 divided by 11 does equal 1. And is 11 divided by 1 11? Because we're replacing the ends with 11. Is 11 divided by 1 11? Okay, can it any other number other than 11 and 1 go into 11? No, okay. Are there any others? What do you think? Sammy? 13, she says. Okay, she says 13 can be circled. So does 13 qualify? 13 divided by itself, 13 is 1. True, class? Okay. And 13 divided by 1 is 13 itself. True, class? Is there anything else, though? We still have to check. Is there anything else that goes into 13 other than itself and 1? It gets divided by itself in the first one. It gets divided by 1 in the second one. Is there anything else that goes into 13? How about 3? No. 7? No? Okay. Okay, another one. Cheyenne?
17.
She thinks 17 qualifies. Okay, 17. Let's try. 17 divided by itself, is that 1? Okay, and is 17 divided by 1 itself? Okay. Anything else going to 17? 3? 7 maybe? Maybe 9? No, you can't think of anything? Okay, well then, I guess 17 qualifies. Do we have any others? Any others in that list that qualify? And there's one more. Sylvia? 19, Sylvia says. 19, so 19 divided by itself is 1. True, class? And when you take 19 and divide it by 1, you get 19. Is that? So it's divisible by itself. We get 1. It's divisible by 1. We get itself. Anything else go into 19? 3, 6, 9. Nothing. Okay. So, and I said there was one more, so do you think we've got them all? Anybody convinced we missed any? What numbers in that list do we know for sure are divisible by something else? No, not necessarily. What numbers do we know for sure? We could have crossed them out right away in the beginning, actually. Danny? The what? 15? Okay, but what numbers could we right away with? I mean, from just what we just did up earlier, what did we say? You know what? These guys can't even begin to possibly be choices. You want to try again, Danny? Even numbers. What are all even numbers divisible by, class? 2. So we could have right away done this. You know what? You guys are not even in the race anymore. Sorry. We could have just crossed out every even number because every even number is divisible by 2. So we can't be in this group. And now the only ones that we have left that we haven't addressed are 15 and 21. And what's 15 also divisible by? 5, 3. How about 21? 7 and 3. Yeah. So I think we have our list. What are these numbers called that we have circled? What are all these numbers called that we have circled? They have a special name. What are they called? Becky? Prime. Prime numbers. P-R-I-M-E. These are members of the prime number set. Prime number set. Okay. Okay, questions at all on those special patterns of numbers? Okay, let's go to the back side now. Sierra thought we were done. Okay, we got one more thing to do, even though it's not up here in our learning goal, because we've actually already learned how to do this, but we're gonna practice it again, because they have to do it in your notes, in your homework again today, so let's have some more practice. So does this, remember this one up here, right here? We are looking today for percent increase problems, percent of increase. So we need to know how much did it change by. We put that over the starting amount. What was it originally? And that should equal the percent of change over 100. We have these in some other notes. So let's take a look at our first one. Last year, the Indiana Hawks won 16 games. This year, they won 20 games. What is the percent increase in their winning games over the last year? So what's important information in here that we're going to underline? Give me something that I think we should underline. Harley, what's one thing? I'm sorry, what?
16 games.
They won 16 games, okay? That was last year, right? Last year they won 16 games. Sammy? This year they won 20 games, so that's important. Anything else? What do we need to find? Let's circle that. What do we need to find? Right there, percent increase. Okay, so look at our model up here. We need amount of change, we need the starting amount, we need a percent of change, and 100. So only one of those things can we fill in an X for. So do we know the amount of change? Okay, can we find it? Let's go over here. Amount of change. Amount can be abbreviated AMT, amount. Amount of change. I bet we can find that. How much did it change by? They won 16 games last year. This year they won 20. What's the change in their winning? Oh, you guys, I'm going to have to keep you here all Christmas break because there's no way that you're going to be able to remember anything when you come back. You can't even remember over the weekend. What are we going to do? Danny?
The mom's the life change was 16.
No.
So we're gonna.
Oh, the starting amount, and then when you read so we're going to do 20, take away 16. Did I hear that right? Okay, what's 20 take away 16, class? 4. Okay, so it changed by 4 games. Okay, so they won 4 more games the second year, basically, what we just found out. Starting amount, do we already know that? What is it? What did they start with? 16, we already know that. We don't have to work to get that. Do we know the amount of change? The percent of change, I mean? Isn't that what we're looking for right here? This is going to be our X right here. Okay, let's start. We have 4 over 16 should be equal to X percent over 100. Okay, we have options. We can rename the one that doesn't have the variable in it. We can try vertical. We can try horizontal. We can, what do you think we could do here? Help me out. Pick yeah. Vertical. Okay, so we're going to go from 100 to X, which would mean we'd have to go from 16 to 4. Is that friendly? What do you have to do to 16 to get 4? Class? Divide by 4. So if we divide that side by 4, we come over here and say the same thing. So we're going to have 100 divided by 4 equals our X percent. What goes into 104 times? Class? 25. X equals 25, and we give it the percent sign, right? Instead of the X having the percent sign, the 25 gets it now. So 25%, what is this? Was it an increase or a decrease? An increase, they won more games the second year. So it's a 25% increase. Okay, let's go take a look at our next one. Prices are going up for gold necklaces. That's because the price of gold has gone up over the last year. Good to know. A 24 karat gold ring last year cost $600. This year it cost $750. What is the percent increase? I'm just going to circle that right away. Looks like we're looking for percent increase. There's our X right there, right? Okay, tell me something that's important. Is there anything we can cross out? You know, are there any numbers in this problem that, you know what, don't use them in this because that would really be really silly. Sierra, can you see any numbers that we might have? 24. That's the carats of gold, but it really has nothing to do with finding the percent of increase. So you know what? Cross it out. Don't be tempted to use it in your setup. Okay, what should we use though? What do we want to underline? Ikea? Last year cost $600. Derek?
This year it costs $750.
This year, $750. Okay, what do we need to find first? Do we know the amount of change? No, we need to find it. So let's come over here and let's show in our notes what we were finding. We're finding the amount of change. And how are we going to find that? And how are we going to find that? Caden? And we're going to take 600 from 750. Take the larger amount and subtract the smaller amount to find how much it changed by. So how much did this change by? Class? $150. This is the amount of change right here. It went up $150, so we should expect a percent that we're going to call an increase. So we start with 150 up. What's underneath it? What did it start at? 600 last year. We're looking for the percent it changed. Anybody up for making this one a little friendlier so we don't have to count on our calculator? Anybody think we can make this friendlier? What do I say when I mean this friendlier? The fraction that doesn't have the x in it? Let's rename it. Let's go over here and say rename. I want you to know that sometimes you look at it and you're like, I don't have to, but sometimes you can make life easier by renaming it. So 150 over 600, because I want to challenge you to be able to do this. What goes into both of those? And give me a nice big number. Sylvia? 50. Good job. 50 goes into both of them. Even if you have to come over here and do something like 150 divided by 50, that one I'm thinking maybe you might not have to, but this one you might have to. 600 divided by 50. What's 150 divided by 50? How many 50s are in 150? 30. Not 30, only 3. Yeah, 3. There's 3 50s in 150. Because there's 2 for every 100, right? So there's 2 for every 100. Oh, I bet we could do that 600 without even having to do long division. 2 for 100, 2 more makes 200. How many are we up to? 4. 2 more makes 300. 6, and if you double 300, don't you get 600?
Yeah.
So if you double 6, you get? Wow, yeah, 12. I already did it for us. It's 12. So maybe I just made this worse. It's very possible. No, I didn't. Okay, that's good. So now we're going to rename it as 3/12 equals X% over 100. So vertical or horizontal? Vertical. Horizontal is not friendly. I'm almost thinking I might have made it worse, but we can go vertical. So what do we have to do to 12 to get 3? Divide by 4. We're going from a bigger number to a smaller. Some of you are writing the wrong thing sometimes. So we need to divide. So now we have 100 divided by 4 equals X%. Well, that sounds familiar. What is it? 25. X equals a 25%. Is this an increase or a decrease again? Increase. You have to keep in mind that things can increase or they can decrease. We don't necessarily always have just increase. Okay, are you feeling like you can do this again on your own, or do we need to practice one more? All in favor of one more? There's shy, and all in favor of starting more? I guess the majority wins. Okay, those of you who would like to do one more, I will give you the answer key that has it already worked out. You can fill it in on your notes. How about that? Okay? Okay, so let's get out some loose leaf.